Hello students, as in this lecture we're gonna see the new exercise, the concept based on the new exercise, that is exercise number 8.4, which is known as the Poisson distribution. As in the last lecture we had covered the exercise number 8.3 concept as well as sum, and your 8.3 exercise, it was based on the binomial distribution, and this exercise, it is based on the Poisson distribution. So what is the difference between these two is what the formula. In binomial distribution we used to apply this formula, yes or no? P of x equals to x ncx into p raised to x into q raised to n minus x. Here we will be using this formula. So in the question it will be clearly mentioned that the Poisson distribution is so and so, okay? Or sometimes they will use the word, like here we used to write like this: x p and then value of p, yes or no? Here sometimes they will give like this: x p m. Okay, so here b stand for what? Binomial distribution, and p stand for what? Poisson distribution. Okay, so that was the difference between these two. The formula was different, and in the question it will be clearly mentioned that the sum, it is based on binomial and the sum, it is based on Poisson. So whenever the sum, it is based on Poisson, so there are small things which you have to understand and you have to remember. As compared to the binomial distribution, this exercise, it is little easy. And here also same exactly, at least and at most word will be there, and I hope you all might be knowing how to solve exactly types of sum, at least and at the at most sum. There we used to apply the concept called as combination, yes or no? And we saw the concept as well as lots of formula which was based on the combination. Here we're gonna use this concept which is known as factorial. This is known as what? Factorial. Okay, so you must know how to find the factorial, and this all things I had explained in the first video lecture only, when we started the exercise number 8.3. There I had explained how to find the answer for the factorial, even the combination concept also, yes or no? So here the formula is what? P x equals to small x equals to e raised to minus m into m raised to x upon x factorial. So here m is known as what? It is known as mean. In this exercise the small m, it is known as mean. Sometimes we can say that it is also known as expected value. Sometimes we can say that the small m, it is known as variance. So in this exercise actually mean and variance, they are one and the same, yes or no? In the previous exercise the mean and variance, it was a difference, but in Poisson distribution the value of mean and the variance, you will get the same answer. So here that's why I wrote here m, it is known as expected value as well as variance, and it is known as mean. And in this exercise mean will be equal to variance. Whatever the value of mean will be there, it will be equal to variance, or sometime variance it will be given in the question, it will be equal to the mean. Okay, so your mean is known as small m. Okay, sometime the m in the question they will use this word parameter, mean, or sometime the parameter and mean will be replaced by the word average. So whenever you come across this word parameter, mean, average, it means that it is a value of m. What do you mean by x? X in simple language we can say to find. Here also what was x? To find, yes or no? So here also it is same. So if it says that exactly you have to find 2, so the value of x will be what? 2. at least 2. So it means x greater than equal to 2. At least means greater than equal to. At most means what? Less than equal to. Yes or no? So exactly means what? P x equals to 2. It means we have to consider only the value of 2. Yes or no? What do you mean by x greater than equal to 2? It means it contains 2, 3, 4 and then goes on. So here as in the last lecture also, when we were dealing the sums with respect to the binomial distribution, there I had explained for at least we can use the shortcut formula. So what was the shortcut formula? Simply write 1 minus p x. Yes or no? Negation of this will be what? Less than 2. So here instead of finding p of 2, p of 3, p of 4, we can find, this is known as a shortcut formula. Okay, instead of finding p2, p of 2, p of 3, p of 4, till where that we don't know. In this exercise, see to it that we don't know exactly till where we have to find. So here whenever you come across the word at least, see to it that you have to apply the shortcut formula only. But in the binomial distribution we used to come to know that till where we have to take. It's all depend on the value of n. So here we don't have the value of n, so we don't know till where we have to take this value. So here whenever you come across the word at least, see to it that you have to apply the shortcut formula only. So here it means what? Less than 2 means what? P of 0 and P of 1. Okay, so at most means what? At most means less than equals to 2. It means it contains 0, it contains 1. Less than equal to means we have to consider the value of 2 also. Yes or no? And this all things actually I had explained when we were dealing with the concept of binomial distribution. Yes or no? How to find the value of exactly, at least and at most. Okay, and why we consider till the value of 0 only. Okay, p of 2, p of 1 and p of 0. We cannot take p of minus 1, p of minus 2 because probability value cannot be negative. So this all small things actually already we had discussed in the previous video lecture. Okay, so as I told, in this exercise we will be using the concept known as factorial. So here we have the formula for the factorial, and this thing also I had explained in the last lecture. Okay, so how to find the n factorial? Simply you have to use the formula n into n minus 1 factorial. It means whenever you have to find 5 factorial, so simply replace this n by 5. So this will be 5 minus 1. Yes or no? So this will be 5 into 4 factorial. Now this further 4 can be written as what? 4 into 4 minus 1, 3. So that means you have to simply, what you have to do, whatever the number you have, simply write that number first and then goes on subtracting one number till where we have to write? Till 1. Why not till 0 or negative number? So if you write till 0 or negative number also, like if I say 5 into 4 into 3 into 2 into 1 into 0 into minus 1, so what will happen? In each and every case, whenever we multiply 0 into any number, so answer will be what? 0. For 5 factorial, answer will be what? 0. Then 4 factorial will be what? Into 0 if we do. So 0 into a number will be 0. Even for the 3 factorial also, the answer will be 0. For each and every factorial, so answer will be 0. So what is the use of the factorial then? So here n, actually we have to take till the value of 1. So I can say that n belongs to your natural number. Till natural number you have to take. We cannot consider the whole number. If you consider the whole number means 0. So here 0 into a number will be 0, and in each and every case the factorial answer will be what? 0. So here we have to consider till 1 only. Okay, so 5 factorial we can write as 5 into 4 into 3 into 2 into 1. 4 factorial we can write as 4 into 3 into 2 into 1. Yes or no? So here 5 fours are 20, 20 threes are 60, twos are it is 120. So this 120 it can be written as 5 factorial, or 5 factorial we can say that is equals to 120. 4 threes are 12, 12 threes are 24. 4 factorial it is known as 24. 3 factorial it is known as 6. 2 factorial it is known as 2. And 1 factorial answer is what? It is 1 only. Because we cannot go backward into 0 into minus 1. Yes or no? Till 1 only we have to consider. And whenever you come across 0 factorial answer is also 1. Why? Okay. Whenever you come across 0 factorial answer will be 1 only. And this also I had explained in the last lecture. Why so? Suppose if I replace the value of n by 1. So 1 factorial we know that it is 1. This one will write same as it is. 1 minus 1 is what? 0 factorial. And we know that whenever we multiply 1 to any number, 1 ones are, 1 twos are, 1 threes are, yes or no? 1 ones are, 1 twos are, 1 threes are, 1 into x, you will get that number, yes or no? So 1 into 0 factorial will be what? 0 factorial. So here we got the answer that 0 factorial actually it is equals to what? 1. 0 factorial it is not 0, because we cannot consider the value of any factorial 0. Yes or no? So here remember 0 factorial is also known as 1. So here I had explained how we got 1. Okay. So once again we'll see the formula here. The formula is very simple. Px equals to x is equal to e raised to minus m into m raised to x upon x factorial, where e raised to is what? Is exponential value. This, the value of this part, it will be given in the exam. Ready-made value you will have this. Okay, you have no need of finding the value of e raised to m by using any concept, by using any formula. You will have this e raised to minus m value, ready-made value, in the question itself. And here m is known as what? Mean. It is also known as expected value. It is also known as variance. And here in this exercise, for exercise number 8.4, see to it that mean and variance are one and the same. Sometime in the question, m will be replaced by the word parameter, mean, average. As in the binomial distribution, n was replaced by many words. Yes or no? Times, as I hope you all might be knowing, n was replaced by many other words. Times, number, selected, yes or no? So like that here, m will be replaced by the word parameter, mean and average. So if in the question, if you come across parameter 3, so that means the value of m is 3. The value of mean is 3, so the value of m is what? 3. The average of so and so is 3, so that means average means what? It is a value of m. So I hope you all understood the concept, what exact concept we have to use in this exercise, and how to apply the exact, at least and at most. And see to it that whenever you come across the word at least, you have to use the shortcut formula itself, because we cannot apply this straight format, because we don't know till where we have to take the value. But in the binomial distribution we used to come to know till where we have to consider, because it was depend on the value of n. So here we cannot guess actually. Sometimes we can guess and sometimes we cannot guess till where we have to take. So that's why in simple language I will say that whenever you come across the word at least, see to that you apply the shortcut one. So let's begin with the first sum. So here we have the first one. If x as the Poisson distribution with m, so m it is known as what? Mean. So here we have the ready-made value of m equals to 1. Then find p x less than equals to 1. So here p less x less than equals to 1 means what? So what do you mean by the symbol less than equals to 1? It means the at most value. Yes or no? As here I had explained, less than equals to means what? At most. Greater than means what? Greater than equal to, at least, and equal to means what? Exactly. Okay, and here we have the ready-made value of e raised to minus 1. Suppose in the question, if the value of m it is not given, still we can find the value of m by using this value. As we know that e raised to minus 1, it look like what? E raised to minus m. Simply compare the value, yes or no? So your minus, okay, when you will see the power, so it is what? Minus 1 equals to minus m. So minus will get cancelled. So m equals to 1. So here we have the ready-made value of m. Already it is given in the question. Suppose sometime it is not given, we don't have the value of m. So from here easily we can find the value of m just by comparing it with e raised to minus m, and see that what is there in place of m? It is 1. Okay, so directly we can write as m equals to 1. Okay, so don't worry about the m if it is not given. So from here you can find your m, or sometime in the question they will use the word parameter, mean or average. From this also we can find, easily we can find the value of m. But for here we have the ready-made value of m, and even we have e raised to minus 1 value, and here we have to find px less than equals to 1. So we'll start with the solution part. So here first we'll write what? Given m equals to 1 and e raised to minus 1 equals to 0.3678. Okay, before writing the formula you will write this step. X, it is equals to, okay, similar to the value of p stand for Poisson distribution, as here we write m, and in the binomial distribution, we used to write b n and value of pb. Means the whole and sole thing in the binomial distribution, it was depend on the value of n and p, and here the whole and sole thing, it was based on the value of m. So here we have the value of m. Without knowing the value of m, we cannot able to find our answer like that. Okay, so before writing the formula, in each and every sum you will write this step, as we used to write in binomial distribution. Yes or no? This step we used to write first, and then after that we used to apply the formula. So after this we can say that the probability mean function of x is given by p of capital X equals to x equals to e raised to minus m into m raised to x upon x factorial. After writing the formula, now we can use the formula. Here in this question we have to find what? P x less than equals to 1. So what do you mean by p x less than equals to 1? It means it contain 0 as well as 1. We cannot take the negative values, because probability, the value of probability and the possibility cannot be negative. So less than 1 means what? We have to consider 1 as well as 0 also. Understood? Okay, so what do you mean by p of 0 and p of 1? That means we have to apply this formula two times. In the first case the value of x will be replaced by 0, and in the second case the value of x will be replaced by 1. Okay, so now it means what? P of 0 and p of 1 means what? We have to consider the Poisson distribution formula two times. We have to take, you have to write this formula two times with respect to 0 and with respect to 1. So now we'll see. E raised to minus m. M is what here for this question? It is 1. So minus 1 into m is what here? 1. For the first thing the value of x is what? 0 upon x is what? For the first one, here we have the value of x as 0 and x equals to 1. Yes or no? For the first case the value of x is what? 0. Then here we have plus. As we know that we have to apply this Poisson distribution formula two times. So first with respect to 0 and next with respect to 1. So e raised to The value of m is what? 1. X will be replaced by what? 1. The value of m is what? 1. Simply what you have to do, replace the value of m and x. That's it. For the first case, it will be 0 and 1. And for the second case, the value of m will be 1 and value of x will be 1. Okay. Now, as we know that we have the ready-made value for e raised to minus 1. So what is the e raised to minus 1? And this value, it will be given for each and every sum. E raised to minus 1, e raised to minus 2, e raised to minus 2, whatever the parameter it is there for the question. So e raised to minus m value, it will be there in each and every sum. Okay, we no need to find this e raised to by using any concept or by using any formula. Okay, so you will have this ready-made value. So in place of e raised to minus 1, we can write as 0.3678 into, as we know that 1 raised to 0, using the indices formula, any number raised to 0 is what? 1. 0 factorial is what? 1. Again, e raised to minus 1, we can write as what? 0.3678 into 1 raised to 1 is what? 1. 1 factorial is what? 1. Okay. So here when you will solve this part, you will get what? 0.3678, as 1 will get cancelled. Here also 1 will get cancelled. So here also we'll left with 0.3678. So when you will add 0.3678 plus 0.3678, okay, so here you will get the value as what? 0.7 3 5 6 8 8 16 14 15 12 13 and 7. So here we got the answer 0.7356 for p x less than equals to 1. So in this way you will present your sum in the exam. I hope you all understood how to apply the Poisson distribution formula, how you will get the value of m from the question. If suppose the value of m it is not given in the question, so they will use the word parameter, mean and average. From the word we can find our answer, or else we can compare this e raised to minus whatever the value here we have with e raised to minus m, so easily we can find our answer of m. Understood? And the next, simply apply the formula, and this is known as the Poisson distribution formula. Before writing this formula, you have to mention this step: pm equals to 1. It means the Poisson distribution formula, it's all depend on the parameter m. Without knowing the value of m, of course we cannot able to find our answer. Got the point? Understood? So in this way you have to present your sum. So let's take one more example. As here in this case, here we have x. Okay, as similar symbol, it is look like similar, p 0.5. Okay, so it means what? X p 0.5. Then find p x equals to 3. X equals to 3 means what? Exactly. Equal to means what? Exactly. Here less than equal to means what? At most. Okay, and here we have e raised to minus 0.5. And in this question clearly we can see that here we don't have the value of m. So we can compare this with e raised to minus m, as clearly we can see that what is there in place of m? It is 0.5. As 0.5 also we can find from here, as when you will compare this with x p m, so clearly we can see that here we are getting the value of m as what? 0.5. Either you can find the value of m from here, or you can find the value by comparing it with e raised to minus m. I hope you all understood how to find the value of m. So for this question we have the value of m, yes or no, and e raised to minus 0.5 equals to 0.6065. So before writing the formula, we'll mention this part, yes or no, and we'll write the PMF of x is given by p x equals to e raised to minus m into m raised to x upon x factorial. So what we have to find? We have to find p x equals to 3. So equal to means what? Exactly. That means we have to find the only the value of 3. No need of finding any other values like 4, 2, 1, yeah, 6. Okay. Equal to means what? Exactly. That means we have to find that particular value only. So here we have p of 3. That means we have to apply this Poisson distribution formula only one time. As here we have in the previous one we saw p of 0 and p of 1. Whenever you come across like this plus, here we have two values, see to that you have to apply the Poisson distribution formula that much time. Suppose here we have p of 0, p of 1, p of 2. It means we have to apply this Poisson distribution first for 0, then for 1, and then for 2. That means indirectly or directly we have to apply this formula for that particular question 3 times. Understood? So here simply we'll replace the value of x by 3 and m by 0.5. So e raised to m is what? 0.5. M is what? 0.5. X is what? For this sum it is 3. Okay, so here we can see the value of x actually it is what? 3. As here we wrote the value of x for the first, in the first case it was 0 and in the second case it was 1 upon x factorial, that means 3 factorial. Yes or no? Understood? So here we have the ready-made value for this. It is what? 0.6065 into, so here when you will multiply 0.5 into 0.5 into 0.5, okay, 3 times. So here you will get what? 5 5s are 25, 25 5s are 125. Yes or no? As there are 3, you will, when you will multiply you will get what? After 3 decimal place you will put the decimal. So when you will multiply 0.5 into 0.5 into 0.5 3 times, you will get 0.125. Yes or no? And 3 factorial, we know that how to write 3 factorial. 3 into 2 into 1. So 3 into 2 into 1. This all things I had explained why we have to write till 1. Yes or no? So 0.6065 into 0.125 upon 3 twos are 6 and 6 ones are, it is 6. So after this, if you want, you can reduce this number. This will be 0.6 ones are 6, 0, 6 ones are 6, then 0, then 8, then 3 3 3 you will get. So here we can write till 0.1010, till up to 4 decimal you can write, into 0.125. So when you will multiply 0.1010 into 0.125, so multiply and see, you will get answer. So here I am writing the answer directly, 0.0126. So multiply and check, you will get the answer 0.0126. Okay, just simply multiply and check, you will get this answer. I hope you all understood how to find the answer. Even for exactly, this sum was based on at most. Okay.